For the past 2 decades, the concept of the smart home has focused on comfort, automation, and connectivity. Lights that respond to voice commands, climate systems that learn user behavior, appliances controlled from a phone. But the next transformation is not about convenience. It is about survival, resilience, and resource independence. An autonomous habitat is not simply a smart home. It is a living system capable of producing its own water, managing its own energy, and operating with minimal dependence on external infrastructure. This shift represents one of the most important transitions in the history of environmental engineering. Urban infrastructure was designed for a different era, one with stable climate patterns, predictable demand, and lower population density. Today, cities face water stress, energy volatility, aging distribution systems, and increasing climate extremes. Expanding centralized networks to meet these challenges is becoming economically and physically difficult. As a result, infrastructure is moving closer to the point of consumption, not at the scale of the city, but at the scale of the building. Each autonomous structure reduces pressure on the larger system while increasing local resilience. An autonomous habitat can be understood as a metabolic system. It has inputs, sunlight, air, and rainfall, internal processes, water production, energy conversion, treatment, and storage, and outputs, clean water, usable energy, and minimal waste. Just like a natural ecosystem, the goal is not linear consumption, it is circular resource flow. Water extracted from air becomes drinking water. Used water is treated and reused. Energy generated on-site powers the entire cycle. Nothing is isolated. Everything is connected. The defining feature of autonomous habitats is integration. Water systems no longer operate independently from energy systems. Waste is no longer something to be removed. It becomes a resource. For example, waste heat from energy systems improves water production efficiency. Treated greywater supports indoor agriculture. Organic waste can generate biogas for supplemental power. This level of integration transforms the building into a self-regulating environmental unit. Climate resilience has traditionally been planned at the scale of regions and cities. But when infrastructure fails, the first impact is always local, at the level of the building. An autonomous habitat maintains water supply during drought, drainage control during intense rainfall, cooling capacity during heat waves, energy availability during grid outages. This transforms resilience from a public service into a built-in property of the home itself. Autonomous habitats are not only a technological evolution, they redefine economic relationships. Homes that produce their own water and energy reduce long-term utility costs. Properties with integrated resource systems gain higher market value. Neighborhoods can exchange surplus resources through microgrids. This creates a distributed infrastructure model where communities become active participants in resource management. Dependence shifts into cooperation. When multiple autonomous homes are connected, a new urban model emerges. Water can be stored and balanced at the district scale. Energy can be shared through local networks. Stormwater can be managed collectively through green infrastructure. This is no longer sustainability as damage reduction. This is regenerative design, where built environments actively restore and support natural cycles. The transition from connected homes to autonomous habitats is not driven by a single technology. It is driven by system design. Environmental engineering becomes the central discipline that links architecture, energy systems, water infrastructure, public health, climate adaptation. In the future, the performance of a home will not be measured only by its size or location, but by its ability to sustain life independently and safely. The home of the future is not connected to infrastructure. It is part of it.